Hello everyone. Today we're going to be looking at how to set up a Midnight validator for the Midnight network, which is a new network by IOG. As far as I know, I think IOG is developing it. So we're going to have this small presentation about the overview of the video, and then we're going to set up the validator from scratch. So Midnight, what is it? To be very brief, it's a blockchain platform designed to empower data protection applications. Like I said, I think it's developed by IOG, as far as I know. But it's a completely separate chain from Cardano, as we'll see soon. So they have their smart contract development environment with the compact programming language, which is based on TypeScript. It is a partner chain of Cardano. Now, what does that mean? Well, I hope we can see soon. It is currently in testnet. So yeah, currently in testnet, Midnight is in testnet, and it's partnering with the Cardano's preview testnet at the moment. We'll see what that means soon. So validators on Midnight, how do they work, right? So basically, Cardano SPOs can become Midnight validators as well. And this means that Midnight can take advantage of the decentralized staking on Cardano for its security. Yeah, basically just if you have a stake pool operator on Cardano, Midnight is saying, okay, we'll just kind of use the same operator. You will register from the Cardano network, make a bridge from Cardano network to the Midnight network so we know which validator is which. And then we'll use the stake distribution from Cardano to inform the block selection on Midnight. So yes, besides that Cardano SPOs can become Midnight validators, any Midnight validator actually must first be a Cardano SPO. What components do we need to run a Midnight validator? First of all, of course, like we said, we need a Cardano stake pool. So the basic component of that is the Cardano node. Usually the setup is a block producing node and relay nodes separated, and the block producer being hidden from the network completely. For the testnet environment, we don't need to have such strict security measures as for production, so you can run a Cardano stake pool on just one node and it can act as both a block producer and a relay. Next is Cardano DB Sync, which is the chain indexer for Cardano node. What it does is take the chain information that the node has and puts it into postgres database so that it's available for querying in a much easier way than it is from Cardano node. Yeah, that's about it, what it does. We do have the Midnight node, which is then the node that's running the Midnight chain, that's creating blocks, syncing and creating blocks on the Midnight chain. This node is will connect to the Cardano DB Sync database to query the stake distribution I mentioned before to inform the block selection. Now I have Kupo and Ogmios here as optional. Why are they optional? Because they are required for the setup, but they are only required for the registration part. So once you register as a validator, you don't need Kupo and Ogmios anymore. The node just needs the DB Sync database. Yeah, you can say they are required, but actually they're optional because there are public endpoints for Kupo and Ogmios, so you can just use those in the registration and you don't even need to set them up. But we will set them up in our setup in this video. Okay, how does it work? I guess I kind of already explained it, but basically Cardano and Midnight are partner chains, so they, well, Cardano operates without Midnight, but Midnight operates with Cardano. So they are interoperable, and the connection is the Cardano preview and midnight testnet 02. We can see all of that in the docs later as well. So that's the first thing, that's our starting point, the two networks being connected, and then the Cardano SPO. So on Cardano preview, creates a set of keys for the midnight network with the pool's cold keys, right? So that we know that this is that SPO. Registers as a block producer for the midnight network through a smart contract on Cardano. So it's just basically a transaction that's registered, that's submitted on Cardano to register for the midnight network. And next is we need to set up dbsync as a dependency for the midnight node. So like we said, the node needs to query the database, the Cardano database. I said only stake distribution. I guess it's also querying the registration things related to the midnight smart contract on Cardano, like the registration and stuff. I'm guessing, but I don't know because the node is closed source, so I can't really know. Well, maybe I can look at the logs, but it's very hard. And finally, the midnight node queries the stake distribution on Cardano to inform its block selection. Well, basically this means that you run the node, you give it an endpoint for the database that you are serving from the dbsync server, and proper authentication and all that. Then the node can connect to this database, it can query the stuff it needs, and it can run sync blocks and also create blocks. And that's about it. So what we're gonna do in the setup is like completely from scratch. I prepared 3 servers, like just clean. So one server is going to have the Cardano stake pool. So it's just gonna be one Cardano node on the preview testnet. We're gonna create the stake pool from scratch. Then the second server is gonna have the dbsync and all the other ones like Ogmios, Kupo and all that stuff. But the main purpose of it will be having the dbsync database on that server. And then the third server will run the Cardano node and connect to the second server, which is serving the Postgres database. So let's get started. All right, so here's the server that the pool is going to run on. And to make the pool, we're going to use the guild scripts as always. So we're just going to run through the setup. The docs are here. Just going to get the guild deploy script. And yeah, I'll post all the links. I have some other links open here related to midnight. We're going to get to those later. Okay, so basically we want to deploy the stuff for the preview and then the selective install. What do we need? So PL, Lipsodium fork, okay. What is the latest binaries? Okay, that's good. Mithril. We could do Mithril. Don't need to. Preview network is small enough, I guess. I don't know. In any case, we're gonna have to wait for dbsync, so it's fine. What else? C we don't need. O we don't need. W we don't need. X we don't need. So we just need P, D, and maybe L. I'll take these 3. So we'll get the binaries and the folder setup and everything Then we just need to run the node. Okay, this is for building. All right, just need some time for this to run. We could at the same time be setting up the other server for dbsync, but I think that would get a bit too complicated for the video. So we'll just do one after the other. Wow, this is really taking its time, huh? Okay. All right, once it's done, we are going to create the pool. So yeah, create the pool. Yeah, just from the menu, create the pool. And then we register. We're gonna need to host the metadata file. Register stuff, and that's it. There we go. All right, so important part here is network is preview, right? We're targeting midnight, so we're creating a pool on preview. Because if we go to the midnight docs here, we will see the supported environments, right? So the preview is connected to the testnet 2, which is the only testnet for midnight right now, and then later mainnet should connect to mainnet and so on. So right now we are doing preview. Okay, we got that installed. So we need to source the src. So now we should have cnode home. Okay, we go to script. How are we gonna register the pool if the node is not synced? Yeah, shit. We need to sync the node. All right, let's use Mithro. Mithro, yes. All right, let's see if I remember how this goes. Is there a Mithro here, right? Well, I guess we can always check the docs. Mithro, yeah. So we just need the client to get the thing, and yeah, Mithro client environment setup. Setting minimum environment, and then we say Cardano DB download. Cool. Need 2 minutes for this. Should have ran it in the background. Because I wanted to check the Mithro env So like when we run the environment setup, yeah, probably reads the files, so it knows it's targeting the preview network. I mean the files in cnode files. All right, so we're gonna have the database synced. We can run the node, we can register the pool. That's gonna be our first step already done. Well, we're gonna need to ask for some delegation. We're gonna ask for the, oh yeah, we're gonna need to ask for delegation, but we also need the test ADA, yeah, when we have our address. All right, we got it. So if we run cnode, it should run successfully. Yeah. So we can just deploy that as the service. Okay. So that should be running now. Guild live view. Okay, it's starting. Sorry. All right, yeah, well, we need to wait for it to start to do the registration. But I guess we can create the wallet. Oh, we can't, okay. Maybe we can with offline. Yeah. Okay, we're just gonna create a CLI wallet. GDP. Okay, right, I forgot to take the address. So I'm gonna request some funds to the address so that I can do the pledge and transaction fees. All right, node is up, epoch 872, tip is good. All right, so we can run CNTools online mode. What do we need to do? Well, we can check if the money arrived. Where is it? Show GDP. We don't have. Okay. Why does it say one asset type? 0 ADA. Okay. All right, maybe the block has not been created. Transaction hash. I guess we need to wait for the next block for this transaction to go in. 29. Okay, so there was a block. So let's see if we have it now. Yes, okay. We have 10,000 ADA. Testnet ADA. So we go pool. We make a new pool. We call it GDP. And then we register the pool. Pledge will be, I don't know, 5,000. Margin, cost. Oh, okay. I thought we're gonna make the metadata here and then copy the file, but no. So we're gonna create the metadata file first. All right, this is the template. GDP. Homepage. Nonce. Whatever. Yeah, that's okay. So the metadata. Oh. URL is more than 64 characters in length. Well, that sucks. What's the length? Okay. I don't know if shortening the URL will work. Okay, it does work for now. Yes, pull registration. Wait, oh, I hit the wrong thing, I think. I don't want DNS. So 5,000 pledge, short URL. Use the existing one. We're gonna enter the relay's address. Gonna run on 6,000. No. Select the owner pledge wallet. It's the one we created. Okay, we need to register the wallet. Okay, I don't want a multi-owner pool. Use separate rewards. No. All right, we're registering the pool now, which is great. So after it's registered, we just need to, okay, we set the pool name in env, and we also need to rotate the keys. Well, maybe it was done, but it doesn't matter. And we need to restart the node. So pool name is GDP. And now if we do systemctl restart cnode, then when it starts again, it should be running in the core mode instead of relay. Yeah, it's already saying core. That's good. Cas current. All right, here we go. Yeah, remaining 62 periods, expires in June, which is in 3 months. Okay, looking good, right? So it's running as a core. That's cool. And in 2 epochs, which is 2 days, it's gonna start producing blocks based on its stake. Cool. Okay, we have the pool, and that's the first step of our Midnight validator setup done. Actually, we still need to request the delegation. So we need the pool ID. Now, which format? Receive pool delegation, pool ID. Is it batch 32? Well, okay, so yeah, I guess the delegation worked, but we need to confirm that. I mean, we don't really, yeah, we need for the, so the more stake we have on the Cardano pool, the more blocks we would be creating on the Midnight network, same as on Cardano, right? So it's good if we have more delegation. We will start producing blocks more frequently on Midnight, so it will be easier to see that everything works. All right, so I don't know if this worked or not. Maybe I should have used the hex for the faucet. I don't know. I guess it would complain though. Yeah, okay. I should have read that first. All right, so it should have gone through. Let's confirm. So we have this pool ID. Yeah, that's us. But we don't see. We still don't see the delegation. That's our pool. All right, so okay, we got 1 million now. All right, so it went through. Excellent. We have our pool info here. Okay, don't need the faucet anymore. That's now really the pool stuff done. All right, so now I opened another server, which is going to be our DB Sync server, or it's also going to be the server where we make the registration for Midnight. So at this point, we can close this stuff probably. So we can look at the docs for Midnight at this point, right? So okay, become Cardano SPO. Basically, we did that, right? There are parts. There are step 1, become a stake pool. Okay, set up partner chain dependencies. Partner chain dependencies is their term for dependencies like Cardano DB Sync, Postgres, Coupa, and so on, so on. We have, okay, yeah, so they changed it a bit. This was in separate repos now. So we're gonna use Docker because that's in the documentation and seems to be working okay for now. So we'll clone this Midnight node Docker thing, and then it has 2 compose files. One is for partner chains, which is going to define a couple of things. So Cardano node, Postgres, DB Sync. Cardano node is like a standalone. It's a node. It's gonna sync. That's fine. It needs a Postgres database. DB Sync needs both the Postgres database and Cardano node, right? So it reads from the node, writes to Postgres, and then we have the optional Ogmios and Kupo that I mentioned that we don't really need, but we're gonna run them. They don't take a lot of resources anyway. So that's that. And then this compose is for actually running the Midnight node. We're gonna use that one later. But both of the files are in the same repo now. So we're just gonna clone this one. Yes, we need to clone. We're gonna clone this one, and we can look at the docs, but basically all we need to do is set the Postgres variables. Now, there's a bit of a problem here with the environment setup on that repo. I'm gonna show you now. And then we're gonna, okay, Docker compose, manage and monitor. That's okay. So I actually have a pull request open here to update some variables, because you see, it's hard coded to PostgreSDB C Explorer, which is fine. You know, C Explorer is pretty standard at this point for DB sync. But the environment variables that are defined in .env are just not used. They are just hard coded in the compose file. So that's why I changed this, because if you look at this repo, then you have the env file, Postgres host. This is not important for this is for Midnight node, and remember, we're not running the Midnight node in this server. We're running the DB sync. So Postgres user, sure, it can be Postgres. I'm gonna replace my password. I'm just gonna put Midnight. Of course, this is not safe, but it's just a throwaway setup. So let's see what we got here. We got the port, we got the user, we got the password, we got the DB. Postgres DB connection string. Also, we don't need for this server because that's only used by the Midnight node. These are Midnight node arguments, and yeah, that's these are fine. Cardano data. For the Cardano data there. Okay. So compose partner chains. We're just gonna replace this Postgres DB, and you see they are actually missing. Yeah, that's actually more important. There's the user is missing, right? So no matter what user you set, it's gonna use the default one, which is called Postgres. And then that might cause authentication issues when you try to log in with the user you thought you created, but you didn't. All right, so we're gonna just fix it. By running this, and then here, like these all match, right? We are using the Postgres user anyway, but they are hard coded, which is not good. Postgres host is Postgres. Yeah, it's this Docker image, right? That's okay. That should be hard coded here. Network is preview. It's fine. Okay, I think that's it. All right, so yeah, we just run Docker compose. Oh, I don't know if we have Docker on this. Yeah, Docker not found. Okay, so I need to install Docker. Yeah. Okay. So we add the repo and then we can install Docker. I think it comes with Compose, right? Of course, it must. Tap. We install the latest. Yeah, Docker Compose plugin. Yes, install. can run this to check if it's working. To just download this hello world image, boom, 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 and okay, hello from Docker, it's working. All right, so now we can Docker compose our partner chains up, and we need to use sudo. Oops. We need to use sudo because you know, on Ubuntu, like you need to add your user to the Docker group or something like that if you don't want to use sudo, but we'll just use sudo for now. Okay, while it's pulling, let's see. Ubuntu Docker without sudo. Yeah, create the Docker group, add the user. Yeah, I can't run commands now. Yeah, create a Docker group, add the user to the Docker group, log out and back in. Okay, you can also run the following command to activate the changes to group, new group Docker, and then verify that you can run it. Did we start with -d? Yeah. Okay, so yeah, it's pulling all the images and it's gonna run them. Okay, Docker already exists. That's good. I guess instead of logging in and out, we can run this, and now I should be able to run like Docker hello world without sudo, and it works. So I should be able to run it without sudo now. All right, so they are running. If I do docker ps, I can see the services running. So what's gonna happen here is Cardano node is gonna sync from scratch. As it's syncing, Cardano DB sync is going to pull all the data into the database, and that's gonna be the slowest part of this. This thing, yeah, we can like check the logs if it is the correct one. Yeah, so it's working, it's inserting blocks, you see. Epoch 2, yeah, it's gonna take a while, probably even 2 days to get up to the tip, but what was I gonna say? I don't know. What I'm doing now is I'm gonna install the PSQL so that I can log in to the Postgres database, right? It's a client for Postgres, and now I can see what's going on here. So I see that the schema was created, right? We have all the tables which hold the Cardano data, and then there you have this query that you can check what's the percentage, the sync percentage, right? So we are not even on 1% now. So you can imagine this is gonna take a while. Later on, we'll need to confirm that we can actually execute this remotely, like connect to the database remotely from the IP of the server that's gonna be running the Cardano node. And we're gonna need to set up the Docker rules for that to be able to connect to the Docker service directly. And we're gonna do that once everything is synced. So at this point, we wait until Cardano DB sync is synced. All right, it's been a couple of days, and now our newly created pool should have started minting blocks. Also, the DB sync of the partner chains dependencies should be synced now, so we are ready to go to the next steps. Let's just see that the pool is running properly. So we're running as core on preview. We have made 3 blocks. So the step 1 of becoming a Midnight validator is complete. That is, we are running a stake pool on the Cardano preview network. All right, so basically we don't need this server anymore. The pool is running here, and that's fine. But we will need an address to register for the Midnight as a Midnight validator. So we need to pay some transaction fees. We need a payment address to pay for that, and we need the pool cold key to associate with the Midnight validator. So we have those here in the priv. We have pool DDP. There we have the cold S key that we will need, and also the wallet. We will need the payment S key and payment V key, signing and verification key. So you will need to copy those over to the server where you're doing the registration. We can close that and go to this one where we were running the partner chain dependencies. I have also already copied this, not the entire priv folder, but I do have the wallet. LS, we have the payment S key and the payment V key, and the same for the pool. We have the cold S key here. All right, so what we wanted to check is that the dependencies are synced. So there are some commands you can run here. Basically ping the service. This is Ogmios, it's on epoch 874, so that seems good. This is for Kupo. Kupo is a bit more cryptic, but I think it's fine. We have most recent tip. This is probably correct. Yeah, we see on the slot 755, yeah, it's the same number. So they are both on the tip, and basically they're going to be synced. If dbsync is synced, Kupo and Ogmios are going to be synced as well, because they're much smaller. Only problem that could happen is some error on runtime, but since we run Docker PS, we see that they are determined as healthy, so everything should be fine. Anyway, for the dbsync, we need to check as well. So we connect to the database and we run the query from before, and now we see the sync percentage is 99.99, which is basically 100% synced and on the tip. So we can say that the dependencies are synced and they are ready to go. There is one more thing here about using Docker and UFW. So we're not going to follow this guide, but it's important to know that basically Docker Compose is not going to respect any UFW rules that you set, I think. So we will get to that later when we are actually trying to connect because we know that we will be connecting to this dbsync Postgres, right? Like we said, the Midnight node will need this service in order to run. But the services, the chain dependencies are synced and we can proceed. So we are going to register as an SPO for Midnight now. We'll need our pool cold key, we'll need the payment keys to cover the transaction, and we need our dependencies synced. We will also need the Cardano node, which we are also running here, of course, right? So we will use this Cardano node Docker container. And yeah, that's about it. We will need to install this partner chains CLI, and two other binaries that we are using for the registration for Midnight. So we can just copy this script and it will, I'm just gonna run it here, copy and run, and it will create this directory. Oh, where did I run it from? All right, I ran it from the home directory. It's fine. I thought I was in the priv pool directory or something. So it will download the binaries, set the permissions, and create this JSON that is the config for the Midnight testnet. We can check this partner chain CLI chain config. We see that it's created okay. And now, one sec, let me see if I can turn the light on. Okay, so we got the binaries, and the first thing we need to do is generate the keys. There is a set of 3 keys: the cross-chain key, grandpa key, and aura key. And we just use this partner-chain CLI generate keys command to create them, and it will create them for us. So we can just run that. It will ask for a base path where we want to store the keys. You can just use the default data. So if we check data now, we have these chains. Actually, I think, okay, we can do tree data. I don't have tree installed. I'm not going to install it now. Basically, this is the structure that's created from the command. And here it's saying we can copy it from this, because it's by default in this partner chains template. We can move it to partner data chains testnet. And oops, I will actually call it testnet 02, because now in Midnight we are officially in testnet 02. So I think even for the Midnight node we need to have this structure of testnet 02, but we'll see that later. Anyway, officially it's called testnet 2, so I'm gonna call it that as well. All right, and we are now ready to start the registration. We have the keys. So we're gonna be using the Docker node, the Docker Cardano node container to execute commands with Cardano CLI. So we'll need to copy our keys to the Docker container so that we can run it, and then later we can remove it with these commands if we want to. So basically, where is that? We need these commands. It's just that my path is a little bit different to this. So I'm home node priv pool pool cold key wallet payment v key. So I'm just gonna edit the commands here, copy them over. Okay, so for me, home node priv wallet payment v key is the path to the verification key on my host machine. I'm copying that to the Cardano node container under data payment verification key. Same thing for the payment S key and the cold key. All right, so that's successfully copied. So the container now has access to the keys, and that we can use in the Cardano chains, partner chain CLI register. So this is the register 1 command. You will see later in the docs we go to register 2 and 3. So there is 3 register commands. So the first one is going to ask us for this Cardano CLI executable. Now we don't have it on the host machine itself. We have it in the Docker container. So to tell the script where to access it, we'll say you run this command, docker execute Cardano node, and inside the Cardano node container you can access the Cardano CLI command. Same goes for the Cardano socket. So we don't have the node running on the host machine itself, it's in a container, so we need to give it the path to the socket, which is located in the container on this path. And now we need the payment keys, so that we copied over. We used the data payment v key, s key, and so on. So we are using the path on the Docker container. And now this is probably gonna fail because it's saying no UTXOs found. So it created a payment address from the verification key, but this address hasn't been used. So we need to send some funds to it. Now I can do that from, well, I guess we can just use the faucet. I was thinking about going to the pool server and sending it. I think this should work because enough time has passed since our last request. Yes. So we requested some funds to the address that was just created. Of course, this will take some time for the transaction to register and the block to be created and put on the chain. So while we wait a bit, we can keep going through this. Basically, when this address is going to be, okay, it's going to give us which UTXO we want to use. We will only have one. And then it will output the command for register to for the next step. Common errors, no UTXOs, can't connect. Okay, I don't think we will hit any. Well, I mean, of course, we hit this one, but okay, we are already solving it. Yeah, we are going to the next step, which is basically copying the output command of register to. That will give us, that will output a command for register 3. It will also ask us, this is the step where we give it the pool S key. It looks like the pool S key can be, oh yeah, the pool S key can be read from the host machine directly. Why? I guess because this one was using Cardano CLI, which is in the container, and the register to command is not using Cardano CLI, so it just operates on the host machine. So there's no need to actually put it inside the container. All right, let's run the register 1 again to see if it finds some UTXOs now. There we go. Okay, so it found this one. So we say, yes, I will use this one. Okay. I copied the register to command and I run it. And now it's asking me for the cold S key. So I'm going to say, I'm going to use my host machine path, home node priv pool call.s key. And now it gave me the register 3 command. Now at this point, we will need the ports and IPs of the dependencies. I will see that later, but there is this warning that we will have an error when we run this, but it's actually expected. We will need to edit the command a bit. So let's just proceed. So I will copy this command, I will run it, and okay, now I'm not sure, can I give it, I think, yeah, again, we are not using the Cardano CLI, so I think I can give it just the host machine path is better. Home node priv wallet payment.s key. That's just to sign the transaction. Okay. So Kupo, by default, yeah, we are targeting the localhost Kupo. The default port is correct for the service that I'm running. which is just the default in the Docker Compose file. Same for Ogmios, localhost 1337. It's correct. All right, node, no such. User bin env node, no such file. So this is a bit of a weird one. Okay. Let's try again. What if we use the one from, yeah, no. Is it node as in Node.js? I think it might be. I think this register command needs Node.js. It does something with Node.js that would explain this, I think. So let's just install Node.js and see. So we run the register3 command again. Home node, priv wallet, payment ASCII, Ogmios. All right, it's better. It's better. Okay, so Node.js is a requirement, not in the docs. Okay, so we have this invalid option, ATMS kind. Now this is in the docs. This is in docs, and it says remove this argument and then run it again. No, sorry, not run it again, but run this. All right, let me show you. So basically this register3 command is going to do some stuff and then construct an external command, and then it's going to run it. So basically this is the command we need to run, but we need to remove this part, ATMS kind plain. So I'm just going to do that. All right, I think I got it. So I'm copying this command here. Is basically, where is the ATMS? So it's just before governance authority. It's just after governance authority and before registration UTXO. So governance authority and registration UTXO here. You see there is no ATMS, so I removed it. And we're gonna run this now. And let's see what happens. All right, a lot of printing. This looks like some Haskell. Oh. Right. It's taking a while, but it seems to be working. There we go. Register committee candidate TX confirmed. Looks promising. Now what we want to do is verify the registration. So we just submitted the registration transaction. We want to see that we are really registered. And now how we do that, there is this RPC for testnet 02. You see, it's called testnet 02, I told you. And then we get, what is this for? This is get status. So I guess we want to get like which epoch it is. In this example, it's 695. And then we want to query for n+2 epochs because that's when our registration will be first seen. So then it gives the final command, which is 697, and then you need to find your key inside the candidate registrations and stuff. Instead of going through this one by one, we have some scripts. I have some scripts here. I stole them basically from the Midnight Discord. And there is one that's called find registration, which basically does this for us. It just reads from the partner chain's public keys and looks up the current epoch and tells us if the registration is found or not, and prints this out, so it's convenient. I'm gonna create the script here. I have the partner chain public keys JSON here, which is needed by the script. So, and I wanted to copy this. Copy the contents, chmod. All right, and we find the registration. So it looks at our key from the public keys. Well, I forgot the file name. Partner chain public keys. It finds it in the candidate registration for n+2 epochs, and then it prints out what is our entry in the candidate registrations. So the most important part is our stake delegation, which is 1 million here, which is correct, right? That's how much we have on our stake pool, and is valid true. That's the most important part. If something is wrong, it would be false. All right, great. So we have registered. We have confirmed the registration. Deregister, we're not gonna do right now, because we want to actually, be registered. But if you want to deregister the Midnight Validator, you can run this. It's important to know that the payment signing key file has to be the same as you used in the registration. All right, so we have done the registration on the server which runs the dependencies, namely dbsync Postgres. This is the one that the Midnight node is going to need. Okay, so we are ready to set up the Midnight node now. The registration is done. The Midnight node has a dependency on the Cardano dbsync Postgres database. So this is the part with Docker and UFW that I mentioned before. We will be connecting. The Midnight node is going to be run on another server. It's going to connect to this server. So we want to set up this server so that we have a whitelisted IP that can connect to the Postgres instance, which is a Docker container. So first of all, the firewall is not running on this server at all. So everything is open right now. We're gonna allow our SSH port so that we enable, well, we can already enable it. Okay, UFV is enabled, and now we need to use this Docker UFW from this repo, and we can download the script that will make the installation for us. But basically what it does is add some rules to the UFW. So we'll just download that. It gives the permissions, and then we can run the ufw-docker install. Okay, we need to use sudo because we are not root. Okay, that's the first thing. And now because this repo shows you how to open a service for Docker that will respect the UFW rules, right? So normally if you set a rule that like denies a connection, if a Docker container is running on that port and the port is forwarded on your host machine, then it won't listen to the UFW rules and you will still be able to connect from it from anywhere. it has things for this, but for specifying a specific container, for specifying a specific IP, it doesn't have it. Actually, it's issue number 6. So service allow from IP, it hasn't been implemented, but this guy found a simple way to do it. So basically you just inspect on the host machine of the container, you inspect the internal IP of the container, and our container is dbsync postgres. So we get the internal IP, and then we run this part, which we will need sudo for, but basically we allow this route from our whitelisted IP. So I need to get now the IP of my server that will run the midnight node. It's this one. From there to my Docker container IP, which I just found on the Docker container port, which for the Postgres is 5432. All right, so we added that rule. And now if we check the status, it looks like this. Right? Okay, so that should be everything we need, I think. We opened this Postgres service only to our IP. Everywhere else is closed. That's good. We might need this server again later because it has some files for the midnight node that we're gonna need. But now we can go ahead and test that we can connect to the Postgres DB from this server. So I have PSQL installed on this server already, so I'm gonna target the host, the dbsync host. This is it. And I'm gonna say the database is cexplorer. The user we set was Postgres. And okay, it's good. It's connecting, right? It's asking me for my password, which I said. I enter the password and it works. I have access to the database from a different server, which is whitelisted. Perfect. This means that we have everything on this server that we need for the midnight node to run. So we can go to step 4. So we basically, the files that we will need that I mentioned from the other server are the data chains testnet that we generated during the registration. Here it's recommending to use magic wormhole. You can use whatever you want to send it. Now let's follow this. So I'm gonna close this one. Okay, open the dbsync one, and now we need to go to partner chains, right? This is where we have the data chains, and then we have testnet 2, right? This is pretty much what we want to send. So we'll install magic wormhole. It's a pretty cool thing. You just say wormhole send, and then you get some secret words, and with those secret words you can receive it on another machine. I don't know how secure it is, but it works. All right, so we're gonna send testnet, in our case 02, and then it gives us the command on the other computer, run this. So I'm gonna close this one, open the midnight node, and I'm gonna receive it. Sorry, I need to install it. I didn't install it on this one. Okay, wormhole receive. Oh, damn it. I think I need to have both of them open, right? Yeah. So you won't be able to actually see that. But I'm just running the wormhole send command on the other server again. And now I got some new words. Gonna run those. Yes, transfer complete now. Okay. Now it worked. So we have the testnet 2 directory on the node server. We're gonna have to pass it to the node in order for it to work properly. Again, we are cloning the same repo that we cloned for the dependencies. This is using SSH, but I'm not logged into Git here, so just gonna clone it with HTTP. And we have, I'm gonna move the testnet folder to the Midnight Node Docker right away. So we have the same thing here. We used the compose partner chains for the dependencies, and there is another compose file here, which is the Midnight Node compose file. And this is what we'll be using here now. So configure the postgres. Yeah, we have the environment file in the repo. We need to edit it. We need to set our Postgres host and the authentication that we are using. And the Docker volume, we will need to set the Docker volume basically for the testnet files that we just copied over, the key store, network, and so on. And we just run docker compose up, and that should be it. So let's edit the .env. Postgres host is gonna be our midnight db sync or preview db sync IP. That's this one. The Postgres port is correct, and the password is just midnight. So it will create the connection string based on these. That's fine. And this looks good. I forgot about the node key. Am I supposed to comment it out here? I think we need to comment out the key. It should automatically read the node key from our testnet files that we're gonna give the node. So I think if you leave it set to an empty string, it's actually gonna error because it's not a valid key, right? And if you comment it out or just remove the line, then it will automatically read from what you give it. This might not be in the docs actually, so yeah, you may get tripped on this, but yeah, I'm tempted to like run it with the empty node key just to show you that it will error. Let's see. Besides that, we need to edit the compose file. So we need to set the volume for the node, basically it's saying we need to have the path to testnet node, but what the thing is, it also expects a specific directory structure. So the directory structure it expects is actually, so we're gonna do our testnet 02, we're gonna copy it to node chains testnet 02. Okay, so in the container, this is what the directory path should be, where the network and key store. So if we do ls on testnet 02, we have key store and network, and so this is the path where key store and network directories should be in. Yeah, I think this should be correct now. So we can run docker compose up. I don't have docker. Okay, we need to docker install on Ubuntu. Already authenticated with sudo, okay. And then we're gonna install this. All right, so let's try to run docker compose up now. It's again we'll just run it with sudo. We need to download the Midnight node image, and then we'll see what happens with the node key. Okay, so it's exited, right? It's so docker sudo docker ps all. Okay, so what I want to do is look at the logs for this. Now if I run docker ps, it's not showing because the container is not running, it exited with an error. But I want to look at the logs, so docker logs, and then I will use this container ID. And here we go, invalid node key, right? Makes sense, it's an empty string, that's not valid. So what we will do is comment this out and try to run it again. And if we run docker ps now it's actually running. And to tail the logs, we can run sudo docker logs, and then we follow the container name, and the container name is Midnight. All right, so the node is starting now. It's executing this thing on our Postgres database. It's creating an index, right? And this table is, I don't know the size, but I'm guessing it's, well, on preview network maybe it's not so huge, but yeah, it takes a while to create an index. And okay, that's done. Slow statement, okay. We see that the Prometheus exporter is has started on 9615, so we can already we have a built-in Prometheus for the node. We can query the metrics, set up a Grafana dashboard for it, and so on. And here we go, we are now syncing, right? The node is running, it's syncing. That's great. Once we reach the tip, and 2 epochs later, we should be starting to create blocks if everything is okay. In terms of the node running, obviously everything is okay. We are syncing, we have peers, and that's good. Now, one other script that's useful is the check keys, also stolen from Discord. This script, I will copy it over, actually needs to run from the Docker container because it's using this 9944 endpoint, which is the endpoint here by the node, and I don't know, we cannot access it outside of the Docker container. So what I'm gonna do is just create this script here, check keys, and if you see, it also needs the partner chain's public keys file. So that's on my server, that the dbsync server that I used for the registration. I'm just gonna copy it over. Just gonna copy those contents over. Partner chains public keys JSON. These are my public keys, and so if we run it from here, yeah, it's not gonna work. Okay, we also don't have jQuery. We can install, it's still not gonna work. Not jQuery, sorry, JQ. I don't know what it stands for, but you see, it's not really working. Also, we can add another echo here so that it prints a little bit nicer. All right, so we need to copy this to the Docker image and run it from the Docker container. Copy to the Docker container, not the image. So we run docker copy, check keys, and we set the container name, which is midnight, and then we can just copy to the root. Hold on, did I forget the syntax? Oh, I need sudo here, right? All right, so that copied the keys, and now partner chains public keys also. Okay, now we want to enter the container. We want to a bash shell in the container, so we do docker exec midnight bash sudo. Okay, that didn't work. What I need IT, yeah, it's like interactive, right? Because this just runs a command. Interactive, like it creates an interactive shell. Okay, so now we are in the you see, we are root inside the container. So here we have the check keys, and also we need to install JQ. We need to update. Okay, check keys, and now we see, does the node have this key? Yes, true, it does. Does it have this key? True, true. Right, so we know that our node has the correct keys, and that's it. Now again, it's we checked the validation, the registration is valid. We check that our node is running with the correct keys. So that's all there is to do. The node is syncing, and we're gonna wait a couple of days again, and then we're gonna see blocks being produced, and that's gonna be pretty much the end of this setup. So it's been a couple of days. The node has been running, the midnight node. It went through a couple of epochs. And by this point, we would expect that it produced some blocks based on the stake that the associated pool has. So if we go to the final part of the docs for Midnight validators, we'll see that when the node is fully synced, we are expecting that it's participating in block production. And these are the logs that we would be expecting to find to confirm that we are producing blocks. This prepared block, pre-sealed blocked. And then there's this line in the docs, successfully proposed block, which there was a short discussion in Discord about. People were worried about they're not seeing this line in the logs. They are only seeing pre-sealed blocks. So does this mean that the node is working properly? Is it relaying its block properly or not? And we were able to confirm that the numbers and the hashes match. So if somebody has a pre-sealed block on their node created with the number and the hash, another node from the network will get the block and will incorporate it into its chain. So everything is working properly, and the node, the Midnight node, seems to not be producing these logs at all. This particular log line successfully proposed block. So when we are looking at the logs, looking for whether we created a block, when, and so on, we are relying on this pre-sealed block. This seems to be the identifier that a block has been made and relayed to other nodes as well. So we can go to our node server and check if we have made any blocks. So like I said, we are relying on the pre-seal line, so we can run the Docker logs, our Docker container name, in my case it's Midnight. We push that to standard out and we grep the pre-seal line. And we see all the logs that start, that have pre-sealed in them. We see that the node has started producing blocks. So now 19th, it's 1 day ago. It was yesterday at midnight. And it's producing blocks regularly since then. The last block was just 30 minutes ago. So this is looking good. The node is syncing, it's producing blocks, and that's all good. I want to show you one last thing, which is actually two things. So one is a script that I also stole from Discord. It's this average pre-seal time, which looks at the logs, basically just what we did here, and calculates the average time that it takes for the node to make a block, like the average time between blocks. So I already have it here, and if we run the script, we'll see that it calculated for me. Average time between blocks is 68 minutes. So on average, every 70 minutes now, the node will create a block. Of course, this is average. It doesn't have to be. We don't have leader logs for Midnight nodes like we do on Cardano, so we don't really know when the node should make the next block. But yeah, everything is working. What I wanted to show is the memory usage. So Midnight node seems to be, at least for now, because testnet 2 is a relatively new chain, it's using only 1.5 gigabytes of RAM. So I'm running it on a server with just 4 gigabytes of RAM. It's a small server, not a strong CPU, not a lot of memory. And I just wanted to show the requirements, and besides that, I'll show the other servers as well. So this is the one that's running all the dependencies on Docker. So it's running Cardano node Docker image, dbsync Docker image, the Postgres database, Kupo and Ogmios, and it's using 6.8 gigabytes of RAM. I have a bigger server for this, because this is the heaviest part of the setup, right? Because it has dbsync, and dbsync is just heavy. These are pretty good numbers because it's preview. On mainnet, it's a lot bigger than this. All right, so that's that one. And just for the sake of it, I will show the one that's running just the Cardano node with the pool. So this one is running just Cardano node. So the Cardano node itself is taking 2.76. So out of those 6.8 on the other one, that's DB sync pretty much. Kupa and Ogmios are relatively small. Okay, that's it. So we went through the complete process of setting up the validator from basically nothing. We did it on 3 separate servers. We connected servers 2 and 3, Midnight Node and Cardano DB Sync. The Cardano pool one is running kind of isolated. It doesn't care about the Midnight Node setup, and the Midnight Node setup doesn't care about it. But we have made the setup a multi-server setup. We started from nothing, right? We created the pool. We created we synced the dependencies. We started the Cardano node, the Midnight node after we made the registration and everything. So this should have everything you need to set up your own as well. Thank you for watching and see you in the next video.